In. As usual, my name is Hakim and I'm going to take you through mathematics, and this mathematics we are going to look at math A, where we are looking at triangles, we are looking at measures, and now we started with the area of triangles. Then again we are going to move on, we are going to look at more about the area of triangles. My dear friend, are we together? Do you have your book? You have your ruler? Do you have your pencil? Is the set there? Okay, I'm calling for your attention. Let us get started. In this lesson, we are now going to look at a triangle, and we say that this triangle, we have different types of triangles. One, we have what we call the right angled triangle, like this one, which has 90 degrees. And then we had what we called the isosceles, whereby this isosceles triangle has opposite sides equal and the base angles are equal. And then we have what we call the scalene, and this one is a scalene angle. The sides are not equal, so this side is not equal to this one, neither equaling to that one. And again we have the triangle whereby all the sides are equal, and this is what we call the equilateral triangle. So this one is an equilateral triangle. Then this one is called the scalene, whereby all sides are not equal. Then this one is called the isosceles, where two opposite sides are equal. And now this one is called the right angled triangle, simply because it has the triangle, the right angle here, 90 degrees. And again we said when you are getting the area of all these triangles, we are using our formula, whereby we say that formula states that half then times the base, then times the height. In the previous video, that's what we looked at. Then today we are now going to look at more and more of these triangle areas. Now suppose if we are given this triangle here, we are having now our triangle A. Are you seeing this one? Now this is our triangle A, then it has its height. So this is a triangle A. Now it has that height. So this triangle is the same area, but again still this same triangle, it can be with the same what? There can be two triangles in one. Now when you look at this triangle, we have this green triangle. Then again I can just change this thing and I do it like this. I think this one. Now this one, it means that now we have two triangles in the same position. My dear learner, please try to observe this. We are having two triangles. Please, if you get this, then what you're going to do, you are going to find it so easy, meaning that we are having now two triangles in the same position. I think that we are having two triangles in the same position. So we have this triangle which is sitting like this, then at the same time we are having the triangle which is sitting over here. So we have this base and also have this base, meaning that there are two triangles. We have this triangle which is standing like this, this is its base. Then we have another triangle whose base is this one. So this is base 2, and now this is base what? Base 1, meaning that this height represents another triangle. So this triangle which is moving like this, so we have this triangle like this one, like this. Then again which is whose base is this one. Then again we have another triangle, this green triangle like this one, so its base is this one, meaning that when you look at this, if now you're following me, take it that we are having two triangles in the same area, meaning that triangle A, it has its area A, then and triangle B has its area B, meaning that or area 2, meaning that area for triangle 1 is equal to area for triangle 2, because they are in the same position. Just they are changing the arrangement, so they are in the same position. So like now, let me take a simple example here. It's like when we have something like this triangle, this rectangle here, then we also get another triangle which is fitting inside here, or so meaning that you have two books, but those books are occupying the same area, meaning that they have the same area. But if now they are not occupying the same area, it can either be here like this one, but if now it is matching with this one, it means that they are in the same area, occupying the same area. In simple terms, to get this one clearly, if you have not again got me, just get your book. When you get that book, you put it down, then you get another book which is of the same size. Then there are two books but sitting in the same area. But now when you have another counter book, a black book, and you get a 96-page book, this small pick fair book, now they are not of the same area. That's why they are not matching. So my dear learner, what you're going to look at today, it is this, whereby we are having two triangles, but these triangles are sharing the same area. I hope that one's understood. So triangle A has the area 1. Then triangle B has its area 2, meaning that area for triangle 1 is equal to area for triangle 2. My dear learner, is that one understood? Yeah. If not understood, please try to send your question, or please try to run the video and you understand it. Okay, now let us go in and see how they can ask this. Alright, now let us change our color here. Let us get a pen, and then after getting the pen, okay, now they can give us a question here. Let us see how we can apply that knowledge we've understood. So they're saying find the height marked h. So they're saying find the height marked h. Find the height marked h here. So let us look at now the drawing. So we are having the triangle. So this is our triangle. Please, I urge you to use a ruler. So aside that, you have nice works. I've seen some people who have sent their work. It is just nice. Please keep up. Alright, so we are having this one. So this is our area 1. I mean triangle 1 has the base as 12 centimeters. Then it has its height as h. Then again we are going to have another height here. So this one, meaning that we have now another triangle whose base is here. So this triangle, its base now becomes 16 centimeters, and its height here, it is 60 centimeters. So now the question is telling us to find the height h. Now what are we going to do? Now we have to apply our mathematics here. We've said now here we have two triangles, they are occupying the same area. So we are now going to say area 1 is equal to area 2, because there are two triangles. So we can take this first triangle to be triangle 1 with area 1. So how do you get the area of a triangle? And that one's obtained as a half a base 1 and height 1, then must be equaling to a half base for triangle 2 and height for triangle 2. I think so. This one means triangle 2, triangle 2, triangle 1, triangle 1, right? Now we are now going to substitute in. So it's now going to be a half, then times our base. Now this is our base 1, which is going to be 12 centimeters, then times our height, and its height is h, which we are finding. So is equal to now the area, because they're in the same area. So this is a half times our base 2. What is base 2? It is 16 centimeters, then times its height. What is the height here? The height is 60 centimeters. Alright, now here we go back as usual. By 2 here 1, then by 2 here it is 66 centimeters times h, so we get 68 centimeters. Now equaling to by 2 1, then by 2 here we have 8. So 8 times 6, so 8 groups of 6. Now we have, that is 8 8, then 8 and 8, then 8 and 8. How many 8s are we having? We are having 6. So this is 16, even now this is 16, then this is 16, now this is 12, not so, then 12 plus this one, it is 8, then we put here 1 2 3 4, so it is 48. So this is 48 centimeters squared. So from here we are now having 60 centimeters h is equal to 48 centimeters squared. Divided by a 60 centimeter divided by 60 centimeters. 60 by 60 centimeter by centimeter will remain with our h. So here we are having 48 centimeters. So centimeter squared, my dear learner, it means centimeter times centimeter out of 60 centimeter. So centimeter goes with 1 centimeter, then by 6 1, then by 6 here we are going to get 8. So our height is going to be, or h is going to be 8 centimeters. So this is how we can apply this. Alright, now let us get another example here. So this other example, they are telling us find the base marked b. So find the base marked b. Find the base marked b. My dear learner, let me hope that we are together. So our triangle is this one, so it is a right angled triangle like this. So this is the base 1, so whereby it is base b, then it has its height. This is the height, which is 12 centimeters. Then we are having another triangle. Now this other triangle, its height is this one and its base is this one. So its base here, it is 20 centimeters and its height is 9.60 centimeters. Alright, so they're telling us to find the area of this triangle, the base of this triangle B. So from our formula we know that it is area 1 is equal to area 2. So for triangle 1, so this is going to be a half base height is also equaling to a half base height. You can put 1 1 2 2, or you can leave it if you have it in your head. I think now you're a good learner, you have it there. Okay, now from there let us now do what? A substitute in. So this is a half. What is the base now? This is base B, so it's now the one we are finding. Then times what is its height? This triangle here, its height is 12 centimeters squared, giving us now a half. Then times the base. Now the base for the second triangle, this triangle here, you are seeing it, my learner? Good. So what is its base? The base is 20 centimeters. Then times the height. What is its height? The height is 9.60 centimeter. All right. And now here we are having now a half base, a half times base, then times 12 centimeters is equal to a half times 20 centimeters, then times. Now this 9.6 I can write it as a what? A fraction. That is from my side work here, you can see it from here, 9.6. we are doing decimals in math B, so I can make this one as a fraction by bringing this decimal here. This is 1 time, that is 96 out of a 10. So then I make this one as 96 out of 10 centimeters. All right, now by 2 here 1, then by 2 we get 60, so we have 60b centimeters, giving us then by 2 1 by 2 it is a 10 centimeter. So we have 10 centimeters times 96 centimeters out of 10. So remember we were multiplying these fractions, so by 10 1, then by 10 1, so we have 1 centimeter times 96 centimeters, so we have 96 centimeters squared. I mean squared, sorry. So it is centimeter times centimeter, giving us centimeter squared. So by 10, so this 10 went with this 10, so 1 times 96 we get this one, centimeter times centimeter, we get centimeter squared, so it's giving us 60b centimeters. What are we going to do? Divide by 60 centimeters to get the value of b, 60 centimeters. So 6 here by centimeter we have b, so b is equal to 96 times centimeter times centimeter out of 60 centimeter, or 6 times centimeter. So by centimeter 1 by centimeter, so by 6 here 1, how many 6s are in 9? We have 1 6 in 9, so how many 6s are in 36? They are 6, so we get 16 centimeters. Therefore b is equal to 16 centimeters. All right, my dear learner, are we still together or you are confused? Let me hope that we are still together. All right, wow. Okay, so let us now change the color. This time let us use this color here, and then let us get our pen, and we move on. All right, so let us look at another one more example. Okay, so let us get our triangle. Find the value of y. All right, so in this triangle we are having a triangle like this one. So this triangle, it has its height here, so it has the base at 10 centimeters. This is y. Then we have another triangle. So another triangle has its height here, and its height is there. So meaning that where you are seeing this one sitting, this one becomes the what? The base. So this one, it is 20 centimeters, and this one is 5 centimeters. So we want to find the value of y. So the y is the height. So from our formula, that is area 1 is equal to area for triangle 2, because they are in the same position. Therefore it is a half base height is equal to a half base height. So this is a half times the first base. We can take this one here, which is 10 centimeters, then times the height for this 10 centimeters. So this is y, giving us now a half times the base. Now the base where this height is sitting, so this is 20. it is 20 centimeters, then times the height of this base 20 centimeters. If you follow this height, its height is 5 what centimeters. So by 2 here, 1 by 2 we get 5, so this one's giving us 5y centimeters equaling to by 2 1, then by 2 here we get a 10, so 10 times 5, that is 50 centimeters squared, because centimeter times centimeter squared, then 10 times 5, that is 50. Alright, so what next here? We are now getting 5y centimeters squared is giving us 50 centimeters squared. Oh sorry, this one's not square, and this one is not square. So we are going to divide by 5 centimeters, divide by 5 centimeter by 5 1 by 5 1 centimeter 1 centimeter 1, so remain with our y. So here we are having 50 times centimeter, that is centimeter squared, then 5 times centimeter, so centimeter by 5 1. How many 5s and 5 1? How many 5s and 0 0? So we have y is giving us 10 centimeter. All right, my dear learner, let me hope that you've understood that. So if you have understood that, try out these numbers. Then exercise A. So we are now going to have exercise A here, our first exercise. It is saying calculate the length of the lines marked with letters. So it is saying calculate the length of the lines marked with the letters. So those who have not handed in their work, please do so. Agaba, I have not seen your work. Jovin, I have not seen your work. Trace, I have seen your work. And others. So those people have not seen their work, so please try to do so. Jonathan, you sent your work late, but again I've received it anyway. Okay, so calculate the length of the lines marked with letters. So our triangle, our first number here. Please organize your work. Organization is very important. You can't get confused. Mathematics is very simple, very simple. So give it time. It's simple. So this is 12 centimeter. Then here we have h. So we are finding that one. Then we have another base here. This is 15 centimeters, and here its height is 80 centimeters. Then our triangle 2, it's just like this one. Please use a ruler. So you have this one like this, then you have another one standing like this. So please use a ruler. Be neat, try to be smart. It costs you nothing to be smart. So here it is x, then this height here, it is 60 centimeters, then here it is 10 centimeters the base. Then triangle 3, we are having triangle 3, it's a right angled triangle just like this one. So you have to use a ruler. Then you have another triangle, so there. Okay, so the base here, it is 20 centimeters. Then the height here, and the height here, it is 6 centimeters. Then the height for this one, it is x. Then the base here, it is 24 centimeters. Triangle 4, number 4 here. Our number 4 here, it is like this. Oh sorry, gosh, let me draw it neatly here. So here, all right. So for me, I don't have a ruler, but you need to use a ruler. So the base here, it is 10 centimeters. Then we have another, we have another height here just like this. This one, the base is 8 centimeters. Then the height here, it is x. Then the height here, it is 80 centimeters. The number 5 here, we are having another triangle here. It is just like this one, like this, like this one here. It has this. Then we have another just here, and it's facing here. So here it is 50, no sorry, this one is 6 centimeters, then its height is x, then this one is 9 centimeters, and its base here it is 4 centimeters. So try out those numbers, then we move on. This is exercise A, and when we are sending this exercise, you have to show it as exercise A. So now still we are moving on with our triangles, area of triangles. Now this time we are going to look at what we call Pythagoras theorem. So this one is known as Pythagoras theorem. Pythagoras, and some people pronounce this one as Pythagoras. My dear Lana, this one is very interesting. It's very simple, but please, you have to get it, you have to practice it. And this is a law, it's a formula which we are going to use later on when you go on studying. You go to senior 1, you go to senior 5, senior 6, university, you'll find where this thing came from. But at our level here, we don't want to confuse our brains, but we have to stick, we have to get it. But later on we shall understand why are we using this theorem, where did this theorem come from. Okay, so this Pythagoras theorem, it's a statement of which you have to get it, and this Pythagoras theorem, we only use it when we are dealing with this triangle. And you know this type of triangle, it is called the right angled triangle. So we only use this theorem here, whereby we are now going to name the sides down. This side is called the base. Now this side is the height, and this is the longest side, which is called the hypotenuse. Now the mathematician who discovered this only applied it on the right angled triangle, and we use this formula or theorem when we are getting the any missing side of a right angled triangle. Are you ready? Right. Okay, so how does this one state? When this man said, when you get base squared and you add this height squared, you are going to get the hypotenuse squared. So when we square the base, the sum of the base squared and the height, the sum of the height and the base squared give us the hypotenuse squared. So it states that base squared plus height squared gives us hypotenuse squared. So to make it easier, we introduce letters and say a squared plus b squared is equal to c squared, whereby c, this is the base, which is a, the height, it is the b, and the hypotenuse, it is the c. So hypotenuse, it is that side which is opposite to the height. So a, b, and c. So a squared plus b squared gives us c squared. Now this is what we are going to apply, and this is what we call the Pythagoras theorem. So we are going to use this one to get the missing side of any triangle. Okay, let us get started. So let us get to our first example, which is saying find the value of x and the area. Find the value of x and the area of the figure below. Okay, so this is our triangle, just like this one, I think. Now it is a right angled triangle. Now here they have given us 5 centimeters, and here they have given us 4 centimeters, and the triangle is A, B, and C. So we don't have this. My dear Lana, I want you to concentrate. Please pay attention. It is very simple, but you are going to make mistakes, and I don't want you to make mistakes because it is very simple. Just follow me. It's very, very simple. Now when you look at this one, so we are going to apply the Pythagoras theorem. Right? Yes, we are going to apply Pythagoras theorem, whereby we said this, we use Pythagoras theorem when we are finding any missing part of a triangle. So we can't get the area, because to get the area, it is half base height, and the height is not given, so we have to first find the height. So this one is A, this one is B, and this one is what? C. So to get this missing side, we are going to use this man's theorem. So that is the Pythagoras theorem, Pythagoras. So we are going to use Pythagoras, which is now saying a squared plus b squared is equal to c squared. So what is our a here? Our a is 4 centimeters, so it is 4 squared centimeters. So my dear learner, take note, don't say 4 centimeters squared. No, we are squaring the number, not the units. It is 4 squared centimeter. Am I understood? Because when you do it like this, this is area, it means that this is area. No, it is that number squared then the unit later. So 4 squared, then plus our b. What is the b? It is now the x, which we don't know, squared, is equal to our c. What is c? It is 5, and we do what? We square c squared centimeters. So 4 squared, it means 4 times 4, right? So that means that 4 times 4, which is giving us 16. So 16 centimeters, then plus x squared, giving us, that is 5 times 5, so that is 25. So 25 centimeters. Now, my dear learner, do you know what are we going to do here? So this one is now calling in for arranging what? So that one is calling in for equations. Remember, it was 16 centimeters plus x squared is equal to 25 centimeters, right? So this is an equation. So we are now going to arrange it. We are going to start with x squared, then plus 16 centimeters, giving us 25 centimeters. So what does this mean? So do you remember from our primary 5, whereby we are looking at simple equations like this one? P plus 2 is equal to 4. Do you remember solving this one, whereby we said we are using additive inverse? So we put a 2 here. So additive inverse, opposite of positive 2 is negative 2, not so minus 2 is equal to 4 minus 2. So this concept here, this is a 2. So this concept here of solving equations is the one we are going to apply here. So we are now going to take 16 this way, which is going to be x squared plus 16 centimeters minus 16 centimeters, giving us 25 centimeters minus 16 centimeters. So here we are having x squared giving us, do you know what are we getting here? 25 minus 16, so we are remaining with the 9 centimeters. But this is a square, so this one is squared. What are we going to do? We are going to get the square root. So from our first terms work, I think, remember getting square roots, and we said the square roots, we get them from square numbers, meaning that which number was multiplied by itself to give us a 9. So the square root for this one, so x is equal to the square root of 9, it is a 3. So x is equal to 3 and 3 centimeters. So if you have forgotten to get a square roots, please try to go and revisit that work and get to know how we get the square root. So our value of x is 3 centimeters, but remember they told us after getting the value of x, we are supposed to get the area, whereby now area is equal to a half base and a height. So our base was 4 centimeters, then now our height we've obtained it as 3 centimeters. So by 2 once by 2 2, so 2 times this one, 60 centimeter times centimeter, we get 60 centimeters squared. Units are very important. All right, okay, let us now get another example. I think you've understood that. Yeah, still we are applying what we call the Pythagoras theorem. Alright, so this example 2 is saying find the value of x and the area of the figure. Still the same instruction, and our figure here, it is this triangle, and it is an isosceles triangle. The moment you see this, so it is an isosceles triangle. Here we are having its height, whereby the height, its height, it's 8 centimeters, and then this one and this one, so they are equal. These symbols show this one and this, they are equal. And again, so from here they are giving us this length up to here, whereby they are giving us 2x centimeters. All right, and again it is triangle A, B and C. And now here they have given us 10 centimeters. Oh, my dear learner, when you look at that triangle, it needs thinking, and it's very simple. You need to understand, you need to look at this triangle and apply some simple logic. Then you come and we solve that. Remember, they have told us to find the value of x. Find the value of x. This is instruction 1. After that, we also find the area. Now, to find the value of x, when you look at this is a full triangle, right? But if it is a full triangle, do you know what we are going to do? We are now going to first break, and we use a half of it. When we use a half of it, I think this half is now giving us a right angled triangle, like this. So this is the height, which is 8 centimeters from here. Then here it is the x. Then here we are having these symbols, and it is 10 centimeters. Now I think now we are now free to use our Pythagoras. Remember, we said it does not apply on these other triangles. It only works on what you call a right angled triangle. Do you remember the theorem? The theorem says base squared, height squared gives us hypotenuse squared, right? So whereby we said this is AB and C, so it states as a squared plus b squared is giving us c squared squared. Now what is our a? Our a is x, so it is x squared, then plus what is our b? It is 8 centimeters, and we said we don't square a centimeter, but we square a number, that is 8 squared. We can ignore the units, or we can take them. 8 squared giving us 10 squared. So we can put the centimeters, or we can leave them aside, then we bring them later. All right. Therefore, what are we having? We are having x squared plus now 8 squared giving us 10 squared. Now from our side work, this means that 8 times 8, now this is the square number, right? So we get 64. So x is squared here plus now 8 squared gives us 64. Then if you have 10 times 10, that is 10 squared, it is giving us 100. So that is also a square number. Alright, so what are we going to do? Solving an equation. Right? Yes. So x squared plus 64 minus 64 together is equal to 100 minus 64. Right? So x squared here is equaling to what you call 36, because if we subtract, let us subtract from here. This is 100, take away 36, so we regroup. This one becomes a 10, we regroup 9, then we bring a 10 here. This is a 4, 9 take away 6. Sorry, this is 10 take away 4, that is a 6, then 9 take away 6, that is a 3, 36. So we come up with 36. Remember, this is squared, so we have to get the square root, then we get the square root. So this one goes, so x is equal to, what is the square root of 36? So which number has been multiplied by itself to give us 36? From our square root knowledge, that is a 6. So x is equivalent to 6 centimeters. So we have obtained the value of x. So what next is to get part b, that is the area. So area of our full triangle here, which is now going to be a half base height. So we are not taking the area of this one triangle, we are taking the area of all of this, so which is going to be a half. Now what is our base? Now this is the base, whereby here x it is 2x, whereby what is the x here? It is 6 centimeters, and here it is 6 centimeters, meaning that 2 times the 6 is giving us 12, or 6 plus 6, that is 12. So our base, I think we are together, our base becomes 12 centimeters. Therefore, what's the height here? The height is 8 centimeters. So by 2 and by 2 here, it is a 6. So we are having 6 centimeters times 8 centimeters. So 6 times 8, that is 48 centimeter, and centimeter becomes centimeter square squared. Hope you've understood this. So it is very easy. Please just pay attention, just follow me. Mathematics is very interesting, very simple. We are using numbers, we are playing with the numbers, so very interesting. All right, okay, let me give you one more example, then I give you an assignment. All right, which example? Let me give you another one, which is very simple. Okay, let me give you this one. Let us try out this one. Here we have a right angled triangle, just like this. Oh, oops, but for you have to use a ruler and you draw it nicely. So inside it has another triangle, like that. And now here we have a P, then here we have a Q, and we have R. Now this is 10 centimeters, then here it can be x, and then here we have 4 centimeters, and here also have 4 centimeters. What's the instruction? The instruction is saying find part A, find the value of x. Find the value of x. I think yes, we can find the value of x, right? Now when we are finding the value of x, what are we going to do? We have a right angled triangle, so we are going to use the Pythagoras automatically. So we are going to use the Pythagoras, which is a squared plus b squared is giving us c squared, right? Okay, now when you look at this right angled triangle, what are we finding? We are finding the value of x. So what is our a? Remember, we are not going to use this inner triangle. When we use this one, we don't know the hypotenuse, so we are going to use this big triangle out. Are you seeing all of this one? We are going to use all of this triangle here. Are you getting that? Because they have given us its hypotenuse. Now what is going to be the base? Now the base is going to range from here up where the hypotenuse is touching. So we are going to take this 4 and this 4. Understood? We are not taking this 4 alone and you take a 10. So we are using this 4 and this 4. Seen that? Good. Okay. Our base now is going to be 4 plus 4, that is 8. So it's going to be 8 squared. Then plus our b. What is b? The height. So that height is going to be the x squared. What is now going to be the hypotenuse? The hypotenuse is now this 10. I think this 10 here. That is 10 squared. Therefore 8 squared we already obtained it previously, that is 64, then plus x squared, which is going to be 100, right? Now we are going to arrange our equation here, which is going to be x squared plus 64 giving us 100, right? So minus 64 minus 60 what? Then x squared is equal to 30 what? 36. Therefore x squared is equal to 36. We get what? The square root and the square what? The square root. So the square root of x is equal to x, and the square root of 36 is what? 6. Therefore our x is equal to 60 centimeters. Alright, so our part B, find its area. Find the area of let me make it clear. Find the area of PQR. So we are finding the area of that triangle PQR. Now we are not finding the area of a whole triangle, but we are finding the area of P, come to Q, then go to R. So this triangle here. So the area is given as a half base and height. So area here is equal to a half. What is the base here? The base now for the triangle, this one. So the base of the triangle here, what is that base there? The base is going to be 4 centimeters. Then what's the height? Then the height is going to be the x. What is the x? The 60 centimeters. So by 2 once, by 2 here, it's going to be s3. 3 times this one, we get 12 centimeters squared. Alright, so let us go into our exercise. I hope you've understood what I've explained. Alright. Okay, so the instructions are find the area, find the area of triangle PQR and the value of x. Meaning that you have first find the value of x, then you go for that triangle. Triangle 1, it's a right angled triangle, just like this one. Then it is, we have this. So this is 8 centimeters. Then this is Q. We have P. Then this is R. So here it is X, and now this one is 10 centimeters. So number 2 here, we are having another triangle. Please give it time, but what I want you to do is to send this work on time. I'm repeating, on time. So this is 12 centimeters. Even here we have 12 centimeters. This is P, Q, and R. So this one is equal to this, so it is 13 centimeters. And here we have X. Then number 3, we are having a right angled triangle facing this way. Here it is 15 centimeters hypotenuse, 12 centimeters and x, please. It is triangle PQR. Then number 5, we are having another triangle. Oh gosh, let me make it clearer here. But this work must be done in math B, in that math A book. So we are having another like this one. So we have another triangle like this. So it is P, Q and R. So from here up to here, they are telling us it is 2x, meaning that this one is equal to that. So the height is 16 centimeters. It is an isosceles triangle. Here it is 20 centimeters. So you have to know how to get a square root, only that. So we have another triangle here. It's a right angle triangle. Then with this one here, so hypotenuse 17 centimeters. So this is QP and R. So here it is 7 centimeters and here it is 8 centimeters, and then here it is x. It is x centimeters. It is x centimeters and 17. Alright, so try out these numbers. I'm waiting for the assignment. Once well done.